question is that if glycolysis requires ATP first, okay, so at the end we get 2 plus 2, 4 net molecules of ATP, like 4 molecules of ATP, but where do these ATPs at first come from? Okay, so it's really simple. The thing to note is that our cells, for example, this is a cell right here, they always have a lot of ATP lying around. Okay, first of all, if this is a mitochondrion, it has produced, for example, 100 units, for example 100 units of ATP. Okay, now this cell will use up, I don't know, 60, 70, 80 units of ATP, but you always have some ATP present in the cell. Okay, and this cell can just take up, for example, 2 of these ATP, use them here, and now when this glycolysis chain starts, we get to ATP. So we took out 2 ATP and now we give these 2 ATP back, but then we get 2 more ATP. Okay, and these 2 ATP can then be used in another glycolysis reaction. So for example, they will be used up in the first 2 steps, but then we get 2 ATP here and 2 ATP here. Okay, so then we still get 2 more ATP. This process can continue, but the thing is that only through glycolysis we will have 2 net ATP that we can use up again. So we get these 2 extra ATP, we can then use these ATP again in another glycolysis reaction. But what we will be forgetting is that we have produced NAD to reduced NAD, that is known as NADH. Okay, we have produced NADH and we also have produced 2 molecules of pyruvate. When we go to the next reaction, so for example the link reaction, the Krebs cycle, the the electron transport chain in the mitochondria, this NAD and this pyruvate, they will generate 36 new ATP molecules. Okay, so we can just take 2 and we get 4 ATP here and 36 at the end. So the cell will never run out of ATP just by using them in glycolysis. Okay, I guess that's pretty simple.